Now let's move to examples. We are going to be solving these examples, just four of them. Four of these examples incorporated uh, the basic rules of differentiations, the exponents, and the exponent and L'Hopital functions, and also the differentiation of trigonometric functions. Even though the examples are not that much, but you are expected to try more examples at your own ends to perfect what has been explained so far. So now we are going to take the examples one by one. I'm starting with y equals to 3x raised to the power of 6 plus 4x raised to the power of 4 minus 3x squared plus 3. Of course, you know that in this example, we'll be applying two basic rules. We'll be applying the basic rules of addition and subtraction, and we are going to also apply the basic rule, the power rule, which I said is the general rule for differentiation. Now, like I said, for example one, we'll apply the general rule and also the basic rule of addition and subtraction. So our dy dx now will be equals to dds of 3x raised to the power of 6 plus ddx of 4x raised to the power of 4 minus ddx of 3x squared, then plus dds of 3. We are differentiating with respect to x. As you can see that y is a function of x. So if we differentiate 3x raised to the power of 6 first, what do you have? If you use your general rule, it becomes 3 times 6 raised to the power of x raised to the power of x minus 1 plus, if we differentiate 4x raised to the power of 4, this will also become 4 times 4 x raised to the power of 4 minus 1 minus, if we differentiate 3x squared, this will become 3 times 2 x raised to the power of 2 minus 1 plus, remember I said if you differentiate a constant, what do you have? 0. Just put a 0, and then you are left with 3 times 6 is 18. X raised to the power of 6 minus 1 will give you what? 5. Plus 4 times 4 is what? 16. X raised to the power of 4 minus 1 will give you 3. Plus 3, sorry, is a minus. We have minus here. Minus what? 3 times 2 is 6. And then x raised to the power of 2 minus 1 will give us x raised to the power of 1, which is the same thing as x. There is no need for us to write 0 again because it makes no difference to what we have here. So this is the final answer for that example 1. We also have example 2, which says, this is example 2. You can see that example 2 uh, is a is a fraction. Example 2 is a fraction, and what do you think we can do first? If I were you, the first thing I'm going to do is I'm going to evaluate or simplify this function of x to its lower term first before differentiating. And how do I simplify? You can see that x over 6 happens to be the LCM of all other terms at the numerator. So you can split them such that your y can be x raised to the power of 9 over x raised to the power of 6 minus 3x raised to the power of 5 over x raised to the power of 6 minus 2x over x raised to the power of 6 and plus 7 over x raised to the power of 6. I'm very sure that you are still very familiar with your law of indices. If we apply law of indices here, what happens? X raised to the power of 9 divided by it will become x raised to the power of 9 minus 6 minus 3x raised to the power of 5 over this one will become x raised to the power of 5 minus 6, because x raised to the power of 5 and x raised to the power of 6, they share the same base. And in law of indices, when you have taken taking the division of two exponents, the powers you take the difference of the powers as it has been stated here, and then for this one it becomes 2x raised to the power. Remember that here 2x is the same thing as 2x raised to the power of 1. So x raised to the power of 1 and x raised to the power of 6, they are sharing the same base. So and you are dividing them. This one become 1 minus minus 6, then plus for 7. Now you know there is an invisible x raised power of 0 beside 7. That's because x raised power of 0 is equals to 1, so it was not written. So imagine that there is still x raised power of 0 here. If there is x raised power of 0 here, what's going to happen? This one will become 7 x raised power of 0 minus 6, right? So at the end of the day, your y will now become x raised power of 3 minus 3 raised power of x raised power of minus 1, right? Then minus 2 x raised power of minus 5, and also plus 7 x raised power of minus 6. Now that I have simplified my y, now that I have simplified my y, it will then be easier for me to apply the addition and subtraction rule. So my dy ds will be equals to us d ds s cube minus d ds 3x minus 1 minus d dx 2x minus 5 plus d ds 7x raised power minus 6. I'm very certain that by the time you practice more questions, you might not need to be writing, separating, might not need, there might not be need for you to be writing DDS of x raised power 3, DDS of, you just differentiate directly from what you have here. So from this now, if you differentiate 3x squared, what do you have? It become 3x raised power of 2, 3x raised power of 2. If you differentiate this one, 3x raised power minus 1, what do you have? You have, remember that there is minus here, and then you want to use your power minus 1 to multiply 3. So to avoid confusion, so let me just show this step. I wanted to skip that step before, but for a better understanding, let me show everything. So for here now, if this one will become minus, there is a minus already outside, so 3 times minus 1, and then you now have x raised power of minus 1 minus 1. And then for this one, you have minus 2 times minus 5, x raised power of minus 5 minus 1. And then plus, you have 7 times minus 6, x raised power of minus 6 minus 1. At the end of the day, what do you have? At the end of the day, what do you have? We have 3x squared. You know, 3 times minus 1 will give you minus 3. So minus 1 times minus 3 will give you plus 3. This one will become plus 3x raised to the power of minus 2. And remember 2. 2 times minus 5 is minus 10. And there is a minus outside. Minus and minus will also give us plus 10. This one will become plus 10 x raised to the power of minus 5. And then the last part will now give us 7 times minus 6. You know, this is taking a positive sign already, and this will give us a negative sign because 7 times minus 6 is minus 42. So multiplying positive by negative, what do you have? You have a negative. So this one will become minus 42 x raised to the power of minus 7. If you want to leave your answer like this, it is fine. But if you also want to go further, you can change all this x raised power of minus 2. It's the same thing as 1 over x raised power. You know your law of indices now. Your law of indices, if you have x raised power of minus n, is the same thing as what? 1 over x raised to the power of what? X raised power of n. So if you use this law of indices, all the term that is taking a negative power, you convert it to this format, and at the end of the day, this one will become 3x squared plus this will become 3 over x raised power of 2 plus this will become 10 over x raised power of 5, and this will become minus 42 x raised power of 7. Although this is not compulsory, that is if you are willing to leave your answer like this. So either of these two is a